Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter called as structure of atom. Now all of you have already studied about the structure of atom. What is an atom made up of? An atom is made up of a center which is called a nucleus, and then you have electrons revolving in circular orbit around the nucleus. The nucleus, as we have studied, is made up of protons and neutrons, and electrons revolve in circular orbit around the nucleus. The number of protons is equal to the number of electrons, hence an atom is electrically neutral. What did I do? I just recapped everything that you have already studied. An atom is made up of a central part where the entire mass of the atom is concentrated. That central part is called as nucleus. Nucleus is made up of protons and neutrons. Protons are positively charged particles. Neutrons have no charge. You have electrons revolving in circular orbit around the nucleus. Electrons are negatively charged particles. The mass of electron is almost negligible. The total number of protons in an atom is equal to the total number of electrons. How do we know this? I mean, it is not how do we know the number of protons is equal to the number of electrons. How did we discover the structure of atom? Now, the structure of atom was discovered by someone called as Rutherford. How did he discover this? He discovered this by doing an experiment called as scattering of alpha particles. What he did was he took a gold foil and he bombarded it with alpha particles. He bombarded the gold foil with alpha particles. Okay, he started, it's like this is a wall, and I start throwing knives or I start throwing balls at the wall. Okay, now what he saw that most of the alpha particles passed through. What he observed was that most of the alpha particles passed through. Some of them were deflected at large angle. Some of them were deflected at large angles, and a very few of them recoiled back. Right? So what was his experiment? He took a gold foil and he bombarded the gold foil with alpha particles. What were his observations? 3 observations. He found that most of the alpha particles passed through. He found that some of them were deflected at large angles, and he found that very few of them recoiled back. On the basis of this, he came up with 3 conclusions. Since most of the particles pass through, the atom must be made up of large amount of empty space. Since most of the alpha particles, see, if I throw a ball to the wall, if there is empty space, the ball will go through. If there is something obstructing it, only then the ball will come back. The fact that most of the alpha particles have gone through is a clear indication that there has to be empty space. That's how he concluded that the atom is made up of large amount of empty space. Second, few of them were deflected at an angle. Now you will have deflection possible only when there is a force of attraction between them, right? Suppose if I throw something, only when the edge hits something will it deflect and go back, right? So exactly that way you had deflection taking place. So if there is deflection taking place, that means there must be some small particle here that must be causing the deflection to take place, and alpha particles are positively charged particles. Had this particular particle here been positively charged, then the alpha particle would have recoiled back, because like charges repel each other. The fact that the alpha particle moved through, that means the charge here has to be negative. That's how he concluded that electrons revolve in circular orbit around the nucleus. Since a very few electrons recoiled back, that means there has to be a very heavy mass. That's the reason why the alpha particle is not passing through. It is recoiling back, that means that mass has to have positive charge. That is the reason why, because of force of repulsion, it is recoiling back, right? So he thus concluded that the entire mass of the atom has to be concentrated at the center, and that center is going to be made up of nucleus. So the structure of atom, as we know, was discovered by Rutherford. How did he find out the structure of atom? He found out the structure of atom by using scattering of alpha rays particle. What is the scattering of alpha rays particle? He took a gold foil and he bombarded it with alpha particles. He found that most of the alpha particles passed through. Some of them were deflected at large angle, a few of them recoiled back. These were his observations. Based on the observations, he came up with three conclusions. Since most of the alpha particles pass through, the atom is made up of a large amount of empty space. Second, since some of them were deflected at large angle, there has to be a negative charge that must be present in that empty space. He called that negative charge as electron. Since very few of them recoiled back, he came up with the conclusion that the center of the atom is where the entire mass is concentrated, and the center of atom is made up of positive charge. So do we understand this? Later, once Rutherford had done this, later then his student discovered that the center, that is the nucleus, is not only made up of protons but is made up of protons and neutrons. Fine, do we get this thing clear? Thus, he also suggested that the structure of the atom is similar to a miniature solar system with the sun in between and the electrons revolving around the nucleus. He said that's exactly how an atom looks like. Instead of sun, you have the nucleus in between where the entire mass of the atom is concentrated, and instead of electrons, instead of planets, you have electrons revolving in circular orbit around the nucleus. Right? All this we have studied in school. All of us have studied about all this in school. Why did I waste all your time teaching you all this? Because all this that you studied in school about atom having a nucleus, proton, neutron and electron in circular orbit around the nucleus is all wrong. Atom does not look like this. This, what you have studied, is all wrong. Question: sir, it is quite possible that you are lying. Our teachers taught us for 3 years, 8, 9, 10, we learned that this is the structure of atom. Now I'm going to first have to prove it to you that this theory that you have studied is all wrong. Then I'll tell you the new theory. Right? Now, let us assume that this, if I go by what you all think is right, you all think that this particular structure of atom is right. If I go by your theory, then let us consider an atom with 2 electrons. Let's consider. Suppose if I have an atom with 2 electrons, if it has 2 electrons, that means it will have 2 protons, right? That means the nuclear charge on it will be +2, right? The electrons, let us assume, are symmetrically placed at a distance of r from the nucleus. This distance is r, this distance is r. The distance of the electron from the nucleus is r. Then the force of attraction between the nucleus and the electron is given by Newton's law. Remember Newton's law of gravitation? He says that any 2 bodies in the universe attract each other with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance. Newton's law states that any 2 bodies in the universe attract each other with a force which is directly proportional either to the masses or to the charge. If I assume the charge on electron to be E, that means the charge on proton will also be E. That means it will directly be proportional to E square. Charge on proton plus charge on electron, right? There are 2 electrons here, so it will be 2E square and inversely proportional to the square of distance. This is going to be the force of attraction between the nucleus and the electrons, right? Now, the force of repulsion, this is the force of attraction. The force of repulsion is given by the formula E square upon 4R square, right? The force of repulsion between the nucleus and the electron is given by the formula E square upon 4R square. Now, it is very clear from these 2 formulas that this denominator is smaller than this denominator. That means the force of attraction is going to be greater than the force of repulsion. The force of attraction between the nucleus and the electrons is going to be greater than the force of repulsion between the 2 electrons. Because the distance between 2 electrons was 2r, that's how I got 4r square. I hope everybody understood. I applied the same Newton's law of gravity. Directly proportional to the charges E and E, and the distance between them is 2r square is 4r square, right? Now since the force of attraction is greater than the force of repulsion, what do you think should actually happen here? If the force of attraction is greater than the force of repulsion, that means the electrons are going to be attracted towards the nucleus. That means they should start moving towards the nucleus. If they start moving towards the nucleus, ultimately they should go and fall inside the nucleus. If they go and fall inside the nucleus, due to the nuclear force, they are going to be completely destroyed because they have negligible mass. That means then the number of protons will not be equal to the number of electrons. That means the atom will then be a charged particle. If the atom is charged particle, that means everything is charged particle. Anything I touch should give me a shock. But does this happen? If this does not happen, that means the electron is not going into the nucleus. If the electron is not going into the nucleus, as per this theory, the force of attraction is greater than the force of repulsion. The electron should go into the nucleus. That means the theory has to be wrong. First drawback of the theory. The theory fails to explain why, in spite of the, why is it that the electrons remain in the same orbit in spite of the force of attraction being greater than the force of repulsion. Fine, do we get this thing clear? Next. Second drawback. The theory fails to explain the exact arrangement of electrons inside the nucleus. Electrons are moving in a circular orbit around the nucleus. At what distance? Rutherford's theory does not tell you that. How much is the energy possessed by them? Rutherford's theory does not tell you anything about that. Or can I just blindly assume that electrons are moving? Okay, if they are moving, where are they moving? At what distance are they moving? Where is the definite answer for that? Second drawback of the theory. The theory fails to explain why or the exact position and the energy possessed by electrons. Fine, do we get this thing clear? Now, if any object is moving, guys, if any object is moving, it is going to possess kinetic energy, right? If it possesses kinetic energy, it is going to give out kinetic energy. Now you have something called as spectra. When energy is given out, you have a line drawn on that particular paper. It's a machine that tells you when energy is given out. Okay? I am going to be moving. Every time I move, some energy is going to be dissipated from my body and there is going to be a line drawn on the spectra. Right? That way I will have a graph with respect to time that will show when I am moving and how much energy is given out by me. Suppose, guys, if I am continuously moving, that means I will be radiating energy continuously. If I am radiating energy continuously, that means the spectra should show continuous emission of energy. I should have a continuous black patch over there. In this case, let's see the case of electrons. According to Rutherford's theory, the electrons are moving in circular orbit around the nucleus. If the electrons are moving in a circular orbit around the nucleus, they should continuously give out kinetic energy. If they continuously give out kinetic energy, that means they should have a continuous spectrum. It is experimentally found out that they do not have a continuous spectrum. They have a broken spectrum. That means the electrons are not continuously moving. They are going to remain stationary for a point of time. Right? They are not continuously moving. They are going to remain stationary for a point of time. You will say, a big deal, sir. What difference does it make if it is moving or if it is stationary? Guys, when any object, suppose if I have this object, when any object is moving, if I leave an object which is in circular motion, if I leave it, it will move in outer direction. When an object is moving in circular motion, there are two forces acting on it. One the inward force, one the outward force. If the electron stops moving, there will be no outward force. So long as the electron is moving in a circular orbit, so long as the electron is in motion, so long as the electron is in motion, there are going to be two forces acting on the body. One will be the outward force, one will be the inward force. But if the electron stops moving, there will be no outward force. What will happen then? The electron will be sucked in by the nucleus. This theory says that the electron is going to stop, because I do not have a continuous spectrum. Since I do not have a continuous spectrum, that means the electron is going to be stationary for some point of time. If the electron was stationary, why was it not sucked into the nucleus? Right? It should have been sucked into the nucleus. The fact that it is not sucked into the nucleus, that means the theory is wrong. Fine, do we get this thing clear? So do you understand the drawbacks of Rutherford's theory? Can we go through the drawbacks once again? First, the force of attraction between the nucleus and the electrons is 2e square upon r square. The force of repulsion between the electrons is e square upon 4r square. This clearly shows that the force of attraction is greater than the force of repulsion. Hence the electron should be attracted towards the nucleus, right? Should start moving closer to the nucleus and ultimately fall into the nucleus, but this does not happen. Second, the theory fails to explain the exact arrangement of electron. Where is the electron kept? How much is the energy that it possesses? Nothing. The theory fails to tell you anything about it. It does not tell you anything about it. Third, the theory fails to explain why we have a line spectrum instead of a continuous spectrum. A line spectrum indicates that the electron has been stationary. A continuous spectrum would indicate that the electron was continuously moving. If I have a line spectrum, the theory fails to explain why should I have a line spectrum. Fine? Another drawback I could say is, if the electron is continuously moving in a circular orbit, it is going to give out kinetic energy. If it is going to give out kinetic energy, its kinetic energy should decrease. Any object, if it is moving, is going to dissipate kinetic energy. If it is going to dissipate kinetic energy, the energy possessed by it will go on decreasing. That means if it is continuously moving, it is continuously giving out kinetic energy. After a certain point of time, the energy possessed by the electron should decrease. As the energy possessed by the electron goes on decreasing, the electron will start coming closer to the nucleus and then go and fall into the nucleus. So if I assume the theory to be correct, all pointers show that electron will fall into the nucleus and the atom will no longer remain stable. But I know for sure that the atom is stable. How do I know that for sure? Because when I touch anything, I don't get a shock. It is not charged. It is electrically neutral. That means it is quite evident from here that the theory that we have studied is wrong. I know it comes like a huge shock. Sir, we studied all this for 3 years and now you are telling us that all that we studied is wrong. And on top of it, to make matters worse, you are also proving it to us that it is wrong. Sad, very sad. Okay? Do we understand the drawbacks of Rutherford's theory? Right? Now, you had another theory that was suggested by a scientist called as Niels Bohr. Right? B-O-H-R. B-O, not B-O-R-E. It's not boring theory, it's Bohr's theory. Okay? This theory was propounded in 1913. Right? This is called as Bohr's atomic theory. Right? Now he based his theory on, let's try to understand his theory. His theory is also called as quantum theory. What do we mean by quantum? Right? According to him, see, any object cannot continuously absorb or give out energy. Any object cannot continuously absorb or give out energy. You will say, sir, what rubbish? The light is continuously giving out energy. What lies you are saying? Very simple. Go home, take your mobile camera and try to video record what is going on your laptop. See what happens. If you record whatever is going on your laptop, you will see that after a certain point of time there will be a black light in between. It will flicker. That flickering shows you that any object does not absorb or give out energy continuously. If any object absorbs energy or gives out energy in small interval of time, suppose if I consider time along x-axis, it gives out energy for this small interval of time, a small amount of energy. This small amount of energy that it gives out is called as a quanta. Right? So this is called as, when you have many quanta, that's called as quantum. So Niels Bohr's theory is a quantum theory. It is based on the energy possessed by the atom and the electron. Right? The theory works on the energy that is possessed by the electron. Why do we get this thing here? So you have, that is your quantum theory. Now he said that, now before I explain to you how the whole theory works, everybody knows about driving. Okay, let's see, how do I start a car? I sit into the car, right? I'm going to press the clutch, get the car in the first gear, release the clutch, press the accelerator. The car starts moving. Press the clutch again, put the car in the second gear, release the clutch, press more accelerator. The car picks up speed, right? Then press the clutch, put the car in the third gear, release the clutch, press accelerator. Now the car is moving at a comfortable speed, right? At a certain distance, I see a signal. What will I do? No, instead of braking, it's at a certain distance. What I'm going to do is, I'm going to get the car in neutral. The car is not in gear. It is moving. Why is it moving now? It is moving because of inertia. It is moving. Why is it moving now? It is moving because of inertia. The car, it was giving certain amount of energy due to the fuel, and now it is moving because of inertia. That is exactly what Bohr said. Bohr said that there are certain orbits where the electron moves because of inertia. When it is moving at a particular distance from the nucleus, it is going to be moving because of inertia, not because it is absorbing or radiating energy. This particular distance he called it as a stationary orbit. So when an electron is in a stationary orbit, it neither absorbs energy nor does it radiate energy. Why does it not do that? Because it is moving purely because of inertia. Fine, do we get this thing here? If the electron is not in a stationary orbit, either it will absorb energy or it will radiate energy. Fine? When an electron jumps from a higher orbit to a lower orbit, it gives out energy. If I want to push an electron from lower orbit to higher orbit, I have to supply it with certain energy, right? So when an electron is supplied with certain amount of energy, it will jump orbit, will go from one orbit to lower orbit to higher orbit, and when it jumps from higher orbit to lower orbit, it is going to give out energy. Fine, do we understand this? Now, he came up with a mathematical explanation as to how where would the stationary orbit be. He said that when the angular momentum of the electron, what is momentum? Momentum is defined as the product of mass and velocity. You learned this when you were doing Newton's law, Newton's second law. Newton's second law tells you about momentum. Rate of change of momentum is directly proportional to inverse force. So it is there in Newton's second law, right? So he said the angular momentum. Newton's law tells you about momentum of a body in a straight line. He said that angular momentum. Now what is angular momentum? Like how linear momentum is given by the formula mv, mass into velocity. Angular momentum is given by the formula mvr, mass, velocity into the radius. So he said that when the angular momentum is equal to h upon 2 pi, then the electron is in a stationary orbit. What is h? H is a constant number. This particular constant number was discovered by a scientist called as Planck. Therefore, this particular constant is called as Planck's constant. Okay. So h upon 2 pi. 2 is already a constant. Pi we know is a constant. 3.14. So he said that when MVR is equal to h upon 2 pi, then the electron is going to be in a stationary orbit. Okay. Okay. Now, he also explained to us one of the drawback was we did not know the energy, or we also did not know how exact location of the electron. Right? Bohr came up with a theory which explained the energy and the exact location of the electron. He said that the exact location of the electron can be given by 4 different parameters. He called those 4 different parameters as 4 numbers. He called them as 4 quantum numbers. He said that the exact location and the energy of an electron can be described with the help of 4 different numbers, and these are called as the 4 quantum numbers. Right? First, the first quantum number, or the energy value, he called it as the principal quantum number. Right? Principal quantum number is represented by the alphabet n. Right? What is principal quantum number? Principal quantum number is the main energy level within which an electron is going to rotate and revolve. It is not only going to revolve around the nucleus, but it also rotates on its own axis. We will come to that a little later. So, principal quantum number is the main energy level in which an electron is going to revolve. Right? So that means if the principal quantum number is say 1, so that is going to be the main energy level, so it will be somewhere close to 1. Contrary to Rutherford's theory, that where he said that the electron is moving in that one particular line of the first orbit, Rutherford said no, it is not one line, but it is close to that particular energy level, first energy level. Right? The principal quantum number of Bohr corresponds to the orbit number stated by Rutherford. What you all called as orbit number in Rutherford's theory is nothing but quantum number in Bohr's theory. Fine, do you get this thing clear? He gave names to quantum number as 1, 2, 3, 4. He called them as K, L, M, N, O. Right? He also stated that the maximum number of electrons that can be there in a principal quantum number is going to be equal to 2n square. Very similar to Rutherford, in fact the same thing as Rutherford. Rutherford had also stated that the number of electrons in a particular orbit is 2n square, where n stands for orbit number. The only difference here is here n stands for principal quantum number. So what you called as orbit in Rutherford's theory, it is called as principal quantum number in Bohr's theory. Fine, do we get this thing clear? Now, so the first thing was principal quantum number. Principal quantum number is represented as m. Now, let us assume that this is the electron. Let's consider Rutherford's theory. Right? According to Rutherford's theory, I'm going to dramatize this. According to Rutherford's theory, the electron is a very, very nice kind of an individual with no vices. So it is going to move in a straight line. So when I talk about an electron, as per Rutherford's theory, it is moving in a straight line. This is how it is moving. This is how the electron is moving. According to Bohr's, this is a dramatized version, please don't write this in your paper. According to Bohr's theory, an electron is an alcoholic person who is severely sloshed. Have you ever seen how a sloshed person moves? He can never move in a straight line. He is always moving zigzag. Right? So that is how the electron is moving as per Bohr's theory. According to Bohr's theory, an electron does not move along a straight line, but it moves in a particular band of energy. It does not move along a straight line, but it moves in a particular band of energy. Right? Let's assume that the nucleus is here. Right? Now, he said that this particular band of energy is further divided, depending upon how close it is to the nucleus, is further divided into 4 different bands. He gave names to each of this band as S, P, D and F. Right? So he said that the electron is not going to move straight as per Euthyphro's theory, but it moves in a band of energies, and those band of energies he called them as azimuthal quantum number. You had principal quantum number. The second quantum number that you have is azimuthal quantum number. The azimuthal quantum number is further divided into 4 bands. He did not call them as bands, but he called them as orbitals. So henceforth, instead of calling them as bands, I am going to call them as orbitals. So the azimuthal quantum number is further divided into 4 different orbitals, which is S, P, D and F. Fine, do you get this thing here? Where S stands for a spherical band, right? He also gave numbers to each one of them. He gave the number to the spherical band as 0. So if I say 0 azimuthal quantum number, that means it is in the spherical band. The maximum number of electrons that you can have in the spherical band is 2. So this is your azimuthal quantum number S. This orbital is called as the spherical band. Its number is 0 and it can have 2 electrons. That's all the information that he gave about this. Right? Next, the second he called as the P band. The P band is dumbbell shaped. I've shown it to you as a straight line, but it is not a straight line. If the electron is in the spherical band, then this is how it is going to move. If the electron is in the P band, it is going to move this way. It is going to move in dumbbell shape. Right? That is the direction in which the electron is going to move. So the P band is dumbbell shaped. He gave it a number as 1. The maximum number of electrons that you can have in the P band is 6. You can have 6 electrons in the P band. Fine, did we get this thing clear? Next, the third band is called as the D band, right? And he gave it as a name as 4-lobe planar structure. It is called as the 4-lobe planar structure. Fine, do we get this thing clear? He gave it, the D band is the 4-lobe planar structure. It can have a maximum of 10 electrons and it was given the value 2. And the last is F band. F band is complicated 3-dimensional shape, right? The number for that was 3 and it can have a maximum of 14 electrons. So SPDF can have 2, 6, 10 and 14 electrons. So in an orbit, the first 2 electrons will be in the S band, the next 6 electrons will be in the P band, the next 10 electrons will be in the D band, and the next 14 electrons will be in the F band. Right? Each of the band was given a particular number that was called as 0, 1, 2 and 3. Right? That is your azimuthal quantum number. Right? Now, the electron is a charged particle. We have learned that if a charged particle moves, it gives rise to a magnetic field. Right? I presume you have done that experiment where you have a wire passing through cardboard and you have iron filings on it, and as current flows through the wire, the iron filings arrange themselves in circular order, which shows that when a charged particle moves, a charged particle gives rise to a magnetic field. Right? Now electron is also a charged particle. It is moving That means it is going to give rise to a magnetic field. So he said that when the electron is moving inside an atom, it gives rise to a magnetic field. Since the electrons are distributed in different orbitals, they are going to move in different directions, therefore they are going to give rise to different kinds of magnetic fields. Right, do you get this thing clear? Now, this was called as the magnetic quantum number. So the third quantum number was the kind of magnetic field that an electron will give when it is moving in a particular orbit. He said that when an electron is moving in the s orbital, it will give rise to only one kind of magnetic field because it is moving in a circle. He gave number to that magnetic field as 0. So if the magnetic quantum number is 0, that means it is moving, the electron is moving in the spherical field, right? It's moving in the spherical orbital, right? Then, if the electron is moving in the p orbital, it can be moving in this dumbbell shaped direction, in which case it gives rise to 3 different kinds of magnetic field, right? It gives rise to 3 different kinds of magnetic field, out of which one of them is similar to the kind of magnetic field given out by the s orbital. He gave number to these 3 magnetic fields as -1, 0 and +1. Similarly, when an electron moves in the d orbital, it gives rise to 5 different magnetic fields. He gave 5 different types of magnetic fields. He gave number to them as -2, -1, 0, 1 and 2. And finally, when the electron moves in f orbital, it gives rise to 7 different types of magnetic fields. He gave numbers to them as -3, -2, -1, 0, 1, 2 and 3. Fine, do you get this? So thus, each electron will now have a magnetic field number also. Right? Okay. He also came up with the theory that the electron is not only revolving around the nucleus, but it is also rotating on its own axis. He said that the electron could either rotate clockwise or the electron could rotate anti-clockwise. Fine, do we get this thing clear? And this rotation of the electron, he stated in another quantum number, which was called as the spin quantum number. What is spin quantum number? Spin quantum number tells you how the electron is rotating on its own axis. Is it rotating clockwise or is it rotating anti-clockwise? Fine, do you get this thing clear? So thus, you have 4 different quantum numbers. Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Fine. What is quantum number? The number that gives you complete information regarding the position and the energy associated with an electron is called as quantum number. With the help of this quantum number, you exactly come to know where the electron is and how much energy is stored in that electron. Fine, do you get this thing clear? Then, how is it that the electrons get filled in the quantum number? Right? Okay, we'll see that part a little later. First, let's recap till here. Everyone's understood up till here? Right? We'll stop this here for the day. Thank you very much.